Okay, so today we're going to be looking at enthalpy, or it's abbreviated delta H, of reactions. To remind ourselves, for chemical reactions, I'm going to write it at the top, that we say reactants yield products. Okay, so our reactants is what we start with, and that is on the left side of the arrow. Notice that the arrow does not mean equals, it means yields. Okay, so keep that in mind, and that's to remind ourselves that reactants yield products. So when we talk about this today, we're going to be talking about heat and energy as terms of a reactant or a product. So we just need to know which side of the arrow means what. And again, the arrow does not mean equals, it means yields. Okay, so enthalpy is defined as the total energy of a system. I'm going to highlight that because that is an important definition. Enthalpy is defined as the total energy of a system. When a reaction occurs, it may produce energy or it may require energy to happen. The enthalpy of a system is influenced by these changes. So when a reaction gives off energy, its change in its enthalpy value, delta H, is negative. Okay, we already kind of know this because we've talked about Q. So Q, in terms of specific heat, is really heat energy of a physical process. So water heating up or cooling down, a piece of metal heating up or cooling down, an object heating up or cooling down. But when we talk about enthalpy, instead of an object heating up or cooling down, it's a chemical reaction that is producing heat or requires heat to make it work. Okay, so we still have the terms endothermic and exothermic, but now we're looking at it in terms of a chemical reaction. Okay, so if it is giving off energy, if a reaction is giving off energy, well, we know that when a process or reaction gives off energy, that's exothermic, so it's still exothermic. And just like Q was a negative Q value, here our enthalpy, or delta H is the abbreviation, is also negative. So likewise, when a reaction requires energy, the change in enthalpy is positive. So just like before, when we were putting energy into a system and Q was positive and it's endothermic, then if a reaction is endothermic and requires energy, then it's also positive. Okay, so the units of enthalpy are joules or kilojoules. So when we really look at the connection here between Q and delta H, we're almost talking about the same thing. Okay, so essentially it's the same thing. One just is talking about a physical process of an object heating up or cooling down, and enthalpy is talking about a chemical reaction requiring energy or giving off energy. But we're still talking about this in terms of joules or kilojoules. So a thermochemical reaction shows the change in enthalpy energy as part of the reaction, either a reactant or a product. Okay, so now that heat energy is a reactant or it is a product. And depending on if it's a reactant or a product will tell us if it's endothermic or exothermic. So an endothermic reaction takes energy from its surroundings to function, and so the enthalpy is a reactant, meaning you have to put it in order for the reaction to occur. So I also want you to circle the endothermic reaction and circle the word reactant and draw a dark line between them. Because if it is endothermic, your enthalpy is a reactant. You have to put it in order for the reaction to occur. It's part of the ingredients of the reaction. Well, if an endothermic reaction has a reactant, then an exothermic reaction gives its energy to the surroundings, so it releases energy as a result of the overall reaction, and so the enthalpy will be a product. So I'm going to do the same thing. I'm going to circle exothermic reaction, circle product, and draw a line between them. And note, when we talk about enthalpy, it is the total energy of a system, because we know that all systems gain and lose energy, but we're looking at as a whole of this system, the sum of the products and the reactants, is it going to be positive or negative? Okay, note that the sign of the enthalpy will be positive when you write it as part of the reaction. So no matter what, when you write it in the actual reaction, it will say plus because you're adding it as either a reactant or a product. But when we pull it out and write it as a delta H, so delta H equals, like we would say Q equals, we're going to add a sign as positive or negative depending on if it is endothermic or exothermic. Okay, so let's look at these two examples. These are just placeholder reactions to show the energy. So in this case, I'm going to box this 15 joules of energy because that is what I'm focusing on. That is my enthalpy. Well, it's a reactant here. And I know that it's a reactant because it's on the left side of the arrow. So it is a reactant. That means I'm adding it to a system. And that means it's endothermic, because I'm adding it to my system. Well, if I look at the other example, my 10 joules is over here. It's written as a product. And I know it's a product because it's on the right-hand side of the arrow, which means that I'm giving it off. It is released as part of the reaction, the overall energy of the reaction. And that means it's exothermic. So endothermic has our enthalpy as a reaction, or as a reactant, excuse me. And exothermic has our enthalpy as a product. So this is what it looks like when we write it in the reaction itself. But we can also write the enthalpy written separately as a delta H value. So here, this is the same reaction. It's the same one. But now, instead of writing the 15 joules as a reactant in the reaction itself, I just pulled it out and say delta H equals. And it's positive here, okay? And it's positive because it's endothermic, because it's a reactant. So I'm gonna say this is endothermic because delta H is positive. It's the same thing that we talked about with Q. When Q was positive, it's endothermic. We put it into the system. Well, when delta H is positive, it's endothermic as a reactant because we're putting it into the system. Likewise, okay, when we did Q and the value of Q was negative, it was exothermic. Well, it's the same thing. Our delta H is negative when it's exothermic. So this is exothermic because delta H is negative. It's really a lot of parallels with Q. Q is positive, it's endothermic. Delta H is positive, it's endothermic. Q is negative, it's exothermic. Delta H is negative, it's exothermic. And we identify what it is based on if it's a reactant or a product. So note that for any reaction, the system is always going to be your chemical reaction itself, and the surroundings are whatever container it is in and us. So when we touch it and it feels hot or cold, then we'll understand that we are part of the surroundings and the reaction is the system, okay? So let's go ahead and look at the examples. And I'm just going to remind myself that reactants yield products. We're going to be looking at several examples, answering some questions, and drawing a heat flow diagram. So we might not be totally comfortable or familiar with the reaction just yet, but we're going to focus in on the heat. So if I look for something with joules or kilojoules, I find it over here, and I'm going to box it. So anytime we see heat as kilojoules or joules, we're going to box it, so that way we know that's what we're focusing in on. Okay, so the first question, is heat a reactant or a product? Well, we boxed it, and it's on the right-hand side of the arrow, and since reactants yield products, this is a product. And based on what we just talked about, because it is a product, that means the reaction is giving it up. It is releasing that energy. So if it is releasing that energy, then this is an exothermic reaction. All right, so the enthalpy value then, so if I say delta H equals, if I pull this out of the reaction, it's exothermic. So is this going to be, like question D, positive or negative? It's negative because it is giving it up. And that answers my next question of a negative value. That's negative 120 kilojoules because it's exothermic, because it's a product. So how do I know? Well, heat is leaving because it's a product. Okay, so if this is occurring and it's exothermic and you touch the container, how's it going to feel? Hot. It's exothermic. It's the same thing that we talked about with Q. It's going to feel hot. The reaction will be hot. Okay, so now let's draw a heat flow diagram. The reaction itself is your system. Okay, so we're going to write out the reaction, and you can just copy what it says up here. So 2 mg plus O2 yields 2 mgO. So our reaction is our system. That means that everything else that is not part of the reaction is part of the surroundings. So that would include you and whatever container the reaction is in or on, the counter, the universe, everything else. So if it's a product, it's exothermic, we have a negative value, which way am I going to draw the arrow? Out. And in fact, I know exactly how much heat is leaving. Negative 120 kilojoules. Negative indicating it's leaving. 120 kilojoules is the amount. And just like before, if heat is leaving, is this endothermic or exothermic? Good. Exothermic. Okay, let's take a look at number 2. So, first thing I'm going to do is find the heat and box it. 252 kilojoules. So now is this heat, and I'm hoping that you answer, now is this heat a reactant or a product? Good. Reactant, because it's on the left side of the arrow. So because it's a reactant, and we're putting heat into the system, is this endothermic or exothermic? Good. Endothermic, because we're putting heat into the system. And reminder, this is your total enthalpy value. So this is the total energy of the system. So I can say delta H equals, what does delta H equal? Perfect. Positive 252 kilojoules. Exactly. It's positive because it's endothermic. It's a reactant. And I just answered the next few questions too, huh? Positive. Ooh, forgot an I. Positive. And we know that it's positive because heat is going in to the system overall. It's a reactant. Okay, so if heat is going into a system and I touch the beaker, how is it going to feel? Cold. It's going to feel cold to me. Good. And that's just generally speaking. So now I'm going to do the same thing I did before with number 1, is I'm going to draw a heat flow diagram. My reaction is my system. So I can just copy what's written here. 2CH3OH yields 2CH3 plus O2. Okay, again, you are part of the surroundings. Whatever container it's in is part of the surroundings, the counter, so on and so forth. Anything that is not the reaction is part of the surroundings. Which way am I going to draw my arrow? Yep, into the circle, and specifically, I know exactly how much heat is going in. A positive 252 kilojoules. And if heat is going in, what is this called again? Good. Endothermic. Okay, so I want to pause real quick and you can come back to 3 and 4, but I want to go down to number 5 because it's a bit of a different structure here for this part of this worksheet. So identify if each of the following are endothermic or exothermic and how they would feel, then write the delta H value. So the first thing to do is find your joules or kilojoules and box it. So 46.1 kilojoules. My next question, it's on the left side of the arrow. So is this a reactant or is this a product? Reactant, so is it endothermic or exothermic? Good, it is endothermic because it's a reactant. So if I touch the beaker, it's endothermic, it's going to feel cold. And my delta H would be, delta H equals? Good, positive 46.1 kilojoules. It's positive because it's endothermic because it's a reactant. Let's look at the next one. Find the kilojoules or joules and box it. So that's my 1428 kilojoules. It's on the right side of the arrow. So is it a reactant or a product? Product. So is it endothermic or exothermic? Perfect. Y'all are doing so good. It's exothermic. So is it hot? Is it going to be hot or cold? And our delta H equals negative. Good. 1428 kilojoules. Perfect. And again, it's negative because it's exothermic, because it's a product, because overall the reaction is releasing that much energy.